All right, today I'm going to talk about electromagnetic waves. We're going to explore the fascinating world of electromagnetic waves, their characteristics, and diverse applications in our daily lives and technology. Electromagnetic waves are around us all the time. We're dealing with them in our atmosphere, in our daily lives. We use them in microwaves, all sorts of different functions. So today I'm going to talk about electromagnetic waves and kind of explain them a little bit. All right, electromagnetic waves by definition are disturbances in an electromagnetic field that move through space carrying energy from one point to another. What that means is they are both electrical and magnetic, but they do not require any kind of medium to pass through, which means no material to pass through so they can travel through space without any kind of material to vibrate in necessity for the wave to move. They consist of an oscillating electric magnetic field perpendicular to each other and the direction of propagation. What that means is if we look at the yellow here, the yellow represents the electric field that is vibrating up and down along this electromagnetic wave, which is represented by the green line. So the yellow vibrates up and down, the wave moves from left to right, and then the magnetic field moves in and out of the screen. So all the fields and the direction that the wave is moving are 90 degrees to each other. So hence the use of the X, Y, and Z axis in this case. Electromagnetic waves have unique characteristics. They oscillate perpendicular to the direction of the wave propagation, which the direction of the wave is moving is what we mean by wave propagation. And they are transverse waves because they are oscillating perpendicular. That's the definition of a transverse wave. Again, they don't require any material to move through, and they are moving at a constant velocity of 3 times 10 to the 8th or 30 million meters per second. The frequency and wavelength are related to each other because the velocity is the same in all electromagnetic waves, 30 million meters per second. As the wavelength goes up, the frequency goes down. And conversely, as the frequency goes up, the wavelength goes down. So each different electromagnetic wave has its own specific frequencies and wavelengths, but they all move at the same speed, that 30 million meters per second. So here is an example of the electromagnetic spectrum and some of the different types of waves that we see on the electromagnetic spectrum. There are radio waves, which are the waves that your radio picks up, microwaves, which are also used in communication, but they are also used in your microwave oven. They are very energetic waves and have the ability to cause vibrations in your food. And that's how microwave ovens heat up your food, is they cause vibrations in the atoms of the food, in the molecules of the food, and those molecules rub against each other, creating friction at a very rapid rate, and allows the food to cook because of the thermal energy being created by friction. Then we have infrared rays, which are heat waves. We can't see them, bees can. We do have devices that allow us to see infrared, such as night vision goggles, things like that. All we are doing there is picking up the heat signature. So these are the waves that we really feel as heat against our body when we're out on a hot, sunny day. Then we have visible waves, and visible waves or visible light are a very, very small portion of the electromagnetic spectrum. They're actually the smallest portion of the electromagnetic spectrum. Everything else has much wider bands to it. And then we have ultraviolet. Ultraviolet means above violet. Those are colors that we can't see, but they are the waves that come from the sun in particular that cause skin cancers. They are high energy, and over time that high energy can cause changes in your DNA, and basically that's what cancer is a change caused in the DNA in specific cells. Then we have X-rays. Obviously, most people know what X-rays are. We can pass those through bodies. They don't pass through bone real well, so we can use X-rays to take X-rays, but basically take pictures of our bones. And then there are gamma rays, and gamma rays are the highest energy waves, and they are produced by nuclear power. They are a nuclear radiation, and we do use those some in specific types of CT scans and things like that as well. So the entire electromagnetic spectrum is used in one way or another for us to transfer messages, transfer energy, lots of different value to us. So here are some applications in communications. We have the radio waves, which transmit audio signals over long distances. We can use the same type of waves for television waves as well. In the case of television waves, we are passing those, and this is becoming less and less normal. Most people are starting to get their television through networks such as cable networks or those type of things. It's becoming less and less transferred by radio waves, but television waves carry both audio and video information. Like I said, they're now being that information is now being transferred more by broadband, satellites, things like that. Mobile phones use microwaves to allow us to have cellular communication networks. And then, of course, satellites facilitate global communications and data transfer by using both microwaves and radio waves. Some of the medical and scientific applications, medical imaging such as X-rays, which I talked about earlier, and gamma rays are used in our X-ray machines and CT scans. We can use radiation therapy to attack cancer as a cancer treatment. Not only does the high energy waves of ultraviolet change our DNA and cause problems with our DNA, which is what cancer is, we can specifically shoot at specific sets of cells with radiation, and the radiation is enough to break up the cell's DNA to the point that it can't survive and kill it. Radiation therapy is becoming more and more the first line of attack with cancer treatment versus chemo. By using radiation, we don't have to use the chemotherapy quite as much, and we don't have to get quite as sick because of that, because basically chemotherapy is doing the same thing as radiation. It's trying to kill the cancer cells while you're trying to keep alive the good cells, and that's what makes you incredibly sick, is the fact that the chemotherapy is chemicals that are attacking cells in your body, and you're hoping that the healthy cells survive and the cancer cells break apart and die. Well, radiation therapy is a little more, not so much a shotgun effect as it is going in and being very surgical about being able to remove or kill off the specific cells that we want to kill off. Now, we do still have to use some chemotherapy in most cases, but not as much. Sterilization, gamma rays, and UV radiation can be used to kill bacteria and viruses and things like that on surgical instruments, our food, things like that. Those materials, while they're harmful to our body, they're also harmful to bacteria's body, bacterial cells, virus cells, things like that. And that allows for us to kill that material using those, and thereby sterilizing medical equipment and things like that. We also use it in remote sensing for weather satellites, understanding what's going on in the environment, things of that nature. Some everyday applications of electromagnetic spectrum that we use. As I said before, microwaves use electromagnetic waves to heat food quickly. Basically, they cause the food to vibrate against itself very quickly. And basically, that's what our body does. As we warm up, our cells are moving faster and faster and vibrating more. This is just a energetic way of doing that and causing friction and allowing heat to build up in the food very rapidly versus trying to transfer energy very slowly with baking and frying and things like that. We also use electromagnetic radiation for GPS systems, being able to find out where we're at. We use lighting every day. That's visible light that we can see that's on the electromagnetic spectrum. And then, of course, security can use infrared radiation for night vision and security cameras, things of that nature. So I hope this helps you understand a little bit better about what electromagnetic waves are and how we can use them in our everyday lives. You have a wonderful rest of your day.